All right, and now we're going to talk about section 2.1, quadratic functions. So a quadratic function, if a, b, and c are real numbers and a is not 0, then f of x equals ax squared plus bx plus c is a quadratic function. The graph is called a parabola, and all parabolas are symmetric with respect to a line that we call the axis of symmetry. The point where the axis intersects the parabola is called the vertex. So a parabola can either open upwards or downwards. We'll have an axis of symmetry right in the middle here. Call that my AOS, axis of symmetry. And the point where the axis of symmetry meets the parabola, that is our vertex. So our quadratics we can put into vertex form. A function, ax squared plus bx plus c, is a quadratic function. By completing the square, we can rewrite it in vertex form as a times x minus h squared plus k. The vertex is h comma k. Notice that it's minus h plus k. So h is the opposite of what it looks like, k is exactly what it looks like. If a is greater than 0, so it's positive, our parabola opens upward, and it has a minimum point where the vertex is. If a is less than 0, so if it's negative, the parabola opens downward, and the vertex is a maximum right up there at the peak. And the axis of symmetry is always x equals h. It is a vertical line that will pass through the vertex. So in vertex form, pretty straightforward. So let's start with this function. Let's start by identifying which way the graph opens. Well, our a value here is negative 1/2. A negative means that it opens downward. The vertex is always h comma k. So it's always x minus h. Well, to get a plus 2, we need it to be a negative 2. So our vertex is negative 2, comma. Remember, it always says plus k, so k must be 6. The axis of symmetry, straightforward. X equals h. Our h here is negative 2. And to determine the extrema, well, we know that the vertex, negative 2, 6, is the extrema, and it is the absolute maximum or minimum. Since my parabola opens downward, it is an absolute maximum. All right, now we have a function that's not in vertex form. So we have to start by writing it in vertex form. And this requires a slightly different step from completing the square. Because we're not really working with two sides of an equation here, we're just going to work on one side. So we start by separating our x terms. So g of x equals negative 2x squared plus 28x minus 99. Then we factor out a. So g of x equals, my a value is negative 2, so I take that out of both of these terms. So I have x squared minus 14x. And now is when we do our completing the square. But it's got a little twist to it. We are going to complete the square inside of these parentheses. And in order to not change the equation, if I add a number, I also need to subtract it if I'm keeping it on the same side of the equation. Sorry, I should have color-coded that better. But remember that this blank will get multiplied by negative 2. So when I add it here, I also need to multiply it by negative 2. And I forgot my x on this 14, sorry. There we go. We determine the value to go in the blank the same way. Our b value is negative 14. We divide it by 2 and square it. Negative 14 divided by 2 is negative 7, and negative 7 squared is 49. 49 is what we're adding and also subtracting. So then, g of x still has that negative 2 in the front. X squared minus 14x plus 49 will factor nicely into x minus 7 squared. Minus 99 minus 49 times negative 2, which makes plus 99. 8. Combine those two pieces. My vertex form is g of x equals negative 2 times x minus 7 squared minus 1. There's my vertex form. So that's what we just had. Which way does this open? Well, our a value is negative 2, so that means it opens downward. The vertex is h comma k. Our h value, x minus h, so h is 7. K is negative 1 in this case, since it's exactly what it looks like. The axis of symmetry is x equals h, so 7. And the extrema, my vertex, 7, negative 1, is the absolute max because the graph opens downward, meaning it is at a peak there. All right, another one to write into vertex form. I'm going to start by separating my x values. 3x squared minus 6x, and this plus 1 is just hanging out. Take the GCF out of there, so f of x equals 3 times x squared minus 2x, still a plus 1. Now I need to complete my square. So I'm going to put a little extra space in my parentheses, and we are going to add some number inside the parentheses, which means if I'm staying on one side, I need to subtract it. Don't forget this 3. That needs to be multiplied by the number we subtract. Now we take our b value, negative 2, divide it by 2, and square that. I get negative 1 squared, which is 1 in both of those blanks. Now we factor. F of x is equal to 3 times x minus 1 squared plus 1 minus 3. So my function is f of x equals 3 times x minus 1 squared minus 2. So there's my function. Which way does this graph open? Well, our a value is 3, so it opens upward. The vertex x minus h, so it's positive 1, plus k, so k is negative 2. The axis of symmetry is x equals h, so x equals 1. The extrema, 1, negative 2, is the absolute minimum in this case because my graph opens upward, leaving me a minimum. Now we're going to take it a step further. We're going to find the x-intercepts and the y-intercept. To find the x-intercepts, we plug in f of x is 0. And then we solve. So I add 2 over. I divide by 3. And then I square root both sides. I get positive or negative square root of 2/3 equals x minus 1. And then we add 1, leaving me with 1 plus or minus the square root of 2/3 being x. We could simplify this and write this better. So a general rule of math, we can split up the square roots for the numerator and denominator. Somebody somewhere said we don't like square roots in the denominator, so we multiply the numerator and denominator both by that square root. I get 1 plus or minus the square root of 6 over square root of 3 times square root of 3 is just 3. This is the best way to write your answer. And then for our y-intercept just means x is 0. So on f of 0, 3 times 0 minus 1 squared minus 2. That's 3 times negative 1 squared minus 2. That's 3 times 1 minus 2. That's 1. And I apologize. We should have written all of these as points. So our x-intercepts are 1 plus the square root of 6 over 3, comma 0, and 1 minus the square root of 6 over 3, comma 0. Our y-intercept is 0, 1. And now we're going to sketch this function. Same function. Let's start with these x-intercepts. 1 plus the square root of 6 over 3. I don't know what that is, so I use my calculator. 1 plus square root of 6 divided by 3. Oops, I didn't want to graph that. Just kidding. 1.81649, so 1.8-ish. Then I can hit second entry and just go back and change that plus to a minus 0.18, so it's about there. My y-intercept is 0, 1. Oops, not that point, that point. Put it at negative, I'm sorry, that's not a point. Okay. We already mentioned our vertex. Our vertex was 1, negative 2. And our axis of symmetry, not something necessary to graph, but that's our axis of symmetry, x equals 1. We know it opens upward. There's my rough sketch. All right, domain and range. The domain, always, every quadratic is negative infinity to infinity. The range, the lowest we go here is negative 2, and we do hit negative 2 up to infinity. We don't need boundedness and continuity. Intervals of increasing, decreasing are constant. It is increasing on the right-hand side of our vertex, so negative 2, 1 to infinity, because remember we use x values. It is decreasing on the left of my vertex, so negative infinity to 1. And it is constant nowhere. All right. And now one more formula for us, the vertex formula. If I don't need to change it into vertex form, I can just use this formula. The x-coordinate of the vertex is negative b over 2a. The y-coordinate just says we plug that value in for y. And then x equals negative b over 2a is the axis of symmetry. So 5x squared minus 25x plus 12. I want to determine which way it opens. Well, my a value is 5, which means it's positive, which means it opens upward. Now we're going to find the vertex using the formula. So x is equal to negative b, b is negative 25, over 2 times a is 5. We have positive 25 over 10, which is, divide them both by 5, I get 5 over 2. To get the y value, we just take h of 5 over 2. 5 times 5 over 2 squared minus 25 times 5 over 2 plus 12. And I am a big supporter of work smarter, not harder. Let's type that in my calculator. 5 parentheses 5 over 2 squared minus 25 times 5 over 2. Ooh, what did I do? That's supposed to be divided by, there we go. Plus 12. Negative 19.25. Let's keep it as fractions. Negative 77 over 4. So our vertex is 5 over 2, negative 77 over 4. And the axis of symmetry should be easy now that we found the vertex. It's x equals the x-coordinate of the vertex, 5 over 2. All right, next problem, we want to determine the way the graph opens. Well, our a value is negative 1, so that means it opens downward. To find our vertex using the vertex formula, x is equal to negative b, which is negative 4, over 2 times a, which is negative 1, positive 4 over negative 2. Our x value is negative 2. Our y value is f of negative 2, which is negative 2 squared minus 4 times negative 2 minus 7. Be careful if you're plugging this in your calculator. You need parentheses around the negative before you square it, because we should get negative 4 plus 8 minus 7, which should give me negative 3. My vertex should be at negative 2, negative 3, which means my axis of symmetry is x equals negative 2. And now, a projectile problem. A stone is thrown from a 100-foot cliff at an initial speed of 20 meters per second at an angle of 30 degrees from the horizontal. The height of the stone can be modeled by this function. All that first information is extra. We care about the function. H of t is height in meters, and t is time in seconds after the stone is released. The time at which the stone will be at its maximum height. I want the x-coordinate of the vertex. That's all this is asking. Really, it's the t-coordinate, but that's fine. So t is equal to negative b over 2a. Well, B is 10. A is negative 4.9. So we have negative 10 over negative 9.8. Let's turn that into a fraction. My calculator can do that for me. I know the negative over negative will become positive. Hit math, frac. 50 over 49 is my t value. So it'll be at its maximum height at 50/49 seconds, which is 1 second and a little tiny bit more. What is the maximum height then? Well, that's the y value of the vertex. So we are going to take h of 50 over 49. So we have negative 4.9 times 50 over 49 squared plus 10 times 50 over 49 plus 100. Again, I will use my calculator here. Negative 4.9 times 50 over 49 squared plus 10 times 50 over 49 plus 100. 105.10204, blah, blah, blah. 105.102, we'll round to nearest thousandths, and we are in meters. And then the time at which the stone will hit the ground. Well, based on my equation, I need to plug in 0 equals negative 4.9 t squared plus 10t plus 100. My guess is that it's not going to factor nicely. So I would go straight to quadratic formula. Quadratic formula, negative b, which is 10, plus or minus the square root of b squared, minus 4 times a is negative 4.9, times c is 100, all over 2 times a, which is negative 4.9. Now, if you get really good at this, you can do this all just in your calculator. Make sure you put parentheses around the whole numerator and the whole denominator. But I can type this all in. So I will type parentheses, negative 10 plus the square root of 10 squared minus 4 times negative 4.9 times 100. Close the numerator, divided by parentheses for the denominator, 2 times negative 4.9. Close that denominator. My first answer is negative 3.6109. Oops, sorry, this is t equals negative 3.611. But that plus or minus, you have to just type it in twice. So I always go second entry, use my over arrow to get back over where that plus was and change it to a minus. Okay, you have to type it in 2 separate times for that plus or minus. You can't just type it in once. So this one is 5.652. Now, if I want the time at which the stone hits the ground, I don't know about you, but I don't have a time machine, so we can't use negative time. The answer is 5.652 seconds. And one more example here for us. A soft drink manufacturer has daily production costs of C, where C is the total cost in dollars and X is the number of units produced. Determine the number of units that should be produced each day to yield a minimum cost. And I lost my function here. Sorry about that. Our function is supposed to be C of X equals 70,000 minus 120X plus 0.055X squared. That'll make our lives easier. So I want to know the number of units that should be produced each day to yield a minimum cost. I want the minimum. That means I want the vertex. And if I just want to know the number of units, that means I just need my X value. So I can use my vertex formula. X is equal to negative B over 2A. Well, B is negative 120. A is 0.055. So I have positive 120 over 0.11, which, type in my calculator, it is approximately 1,090.909. But I'm making soft drinks. I can't make 0.909 of a soft drink, so we're going to round it to about 1,091 units, whatever we want to call them.